like I said, we are having a look at revising our algebra today. And pretty much if you decide to do maths from grade 10, every single section that you do, even if it's not labeled the algebra section, you're going to do algebra. Okay, so, sorry guys, I'm so ready for this term to end. So basically what I mean by that is even in geometry, you're going to use algebra. Even in finance, you're going to use algebra. Even in, I'm trying to think of sections. Trigonometry, which you start in grade 10, you're going to use algebra. So algebra is very much the foundation of maths. And so we need to, like I say, like cement it, get it right, make sure that we know what's going on. Okay, so really importantly, when it comes to algebra in grade 8, there's two important sort of sections, for lack of a better description, that we work with. We work with algebraic expressions, as I have here, and then algebraic equations, which we'll chat about in a second. There's a couple important things that we need to remember when we talk specifically about algebraic expressions. These things do then start to apply when we get to equations. But again, we'll chat about equations when we get to equations. So the first really important thing that we need to bear in mind when we start working with algebraic expressions is that our expressions are made up of terms. And importantly, terms are separated by plus and minus signs. Now, that's a really important bit of information to know, because if you know which terms you are working with, when you then have to simplify an expression, it makes it a lot easier. And this leads on to sort of the green points that I have going on here. Sorry, guys, it's like this rain is crazy. All right, so when we do want to simplify an expression, there's basically 3 steps that we need to follow. Obviously, as the expressions get a bit more complex, we need to start thinking about that. But if we can follow the 3 basic steps here, we should be okay when we need to simplify an expression. So the first thing that we always want to do is identify our terms. Because like I said earlier, if we know what terms we're working with, we know what simplification steps we need to do. Once we know what terms we have, we need to simplify each individual term. I don't know why I didn't highlight simplify, but anywho. And once we've simplified each of the terms making up our expression, we start then looking for like terms. Okay, and like terms, that's where we start to add and subtract our values. Now, just as a quick sort of side note, please remember like terms have the same set of variables, which also have the same exponents. Right, so for example, x and x squared are not like terms because the exponents are different. X squared y and xy squared are not like terms because the x's and the y's have different exponents. Now, we've spoken about like terms a lot, so you should know what it is, but just as a quick refresher, that is what we're talking about when we talk about like terms. Alrighty, so I'm going to give you 2 seconds to take a screenshot of that if you want, and then we're going to have a look at simplifying some expressions. Okay, so if you don't have your screenshots, take it now. I'm about to move away. Okay. Right, so guys, if we have a look at our first question that we have here, we are going to simplify this expression. Now, I've just added a little bubble here for ourselves, that what we need to remember is that when we add or subtract like terms, our exponents do not change. Now, that's really important. When we add or subtract like terms, the exponents don't change. They stay exactly the same. So if we said x plus x, the variable remains x. It doesn't become 2x squared. It just is 2x. So it's really important that we don't start messing with things that we shouldn't be messing with. We just add or subtract. Okay, so remember 3 steps. First step, identify my terms. What I do to identify my terms is I look for my plus or minus signs. And so in this expression, I have got 3 terms. The plus or minus signs separate my terms. So that's how I know I've got 3 terms. Once I know what terms I have, I check and see is there any simplification I can do of the terms. So basically what that means is, can I simplify 7xy? Can I simplify 3xy? Can I simplify 5xy? Now you will know if you can simplify them because you will then need to either multiply, apply an exponent, do some division. If there's none of that going on, we're sorted. There's nothing I can do with these terms. 7xy, it's 7xy. It's not being multiplied by anything. It's not being divided, nothing like that. So it is what it is. So those are my first 2 steps done, nice and easy. The next thing I now want to do is I want to look for my like terms. Now remember, as we said earlier, I can't really see it anymore, but it's the same variable with the same exponents. If I look at my terms that I have, I've got a 7xy, so the variables are x to the power 1, y to the power 1. I've got 3xy, so the same set of variables with the same exponents, and 5xy, again, same set of exponents, variables, same set of exponents. So these are all like terms. Now, if you want to grab a highlighter and highlight your like terms, that's fine. But because we know they're all like terms, we can now add or subtract. Now, guys, you need to think of like terms the same way you would sort of add values. You're not trying to change anything drastically when it comes to the variables. You've got 7xy's in one group. You're adding another 3xy's, and then you're adding another 5xy's. You still have only xy's, but now you're grouping all of them together. So 7xy plus 3xy gives me 10xy. If we do this step by step. Then we still have to add the 5xy. So 10xy plus 5xy is 15xy. Now, grade 8s, I do not expect you to do it step by step. If you're happy to go straight from question to answer, do that. There's no need to go first 2 terms added together, then only the 3rd term. If you are happy to do it all in one go, do that. But if you need to break it down for yourself and go term by term, that is also absolutely fine. Remember, I said this to you before. Find a way that works for you, and that's what you do. It doesn't matter if it looks a bit different to your friends or your teachers. Mathematically, as long as it's correct, you will get the marks. Right, so back to my little bubble, please notice how the x and the y stayed exactly the same. The exponents did not change. I started off with xy, I ended off with xy. Nothing changed in terms of my variables exponents. Okay, so let's take a screenshot here. If anyone has any questions, now's the time to raise your hand. Also remember, guys, although you know this, if at any point you have questions, please just pop them in the chat and I will get to them. But like I say, if at this point you've got questions, you're welcome to raise your hand. Otherwise, I'm going to move on in a second once you've got screenshots. Okay, cool. It's nice and easy to start off with. Add our like terms, nothing too stressful there. Right, so when we get to question B is a little bit different because now I've got some new operations that I'm dealing with. Now I've got some multiplication. But our 3 steps don't change. We're going to identify our terms, we're going to simplify each of our terms, and then we're going to add or subtract any like terms that we have. Now, this little bubble that I have over here is going to come into its importance when we do the multiplication. So really importantly, when we multiply or divide, the exponents will change. Now, guys, the reason that they will change is, remember, because of all of our exponent rules or exponent laws. I'm going to say laws because that's what I use, but if you say rules, that's fine. For example, if we've got x squared times x cubed, we know that the rule is to add the exponents. If we had x to the power 7 divided by x to the power 5, we know the rule is to subtract the exponents. We know that there's more laws that we're dealing with, but just as an example. So really, really importantly, is that when you start to multiply with variables, you do remember your exponent laws. Okay, Steph, I do see your questions. I'm just going to finish this one and then I'll go back to your question for A. So let me just finish this and then I'll deal with that. All right, guys, so the first thing that we do is we identify our terms. So remember, terms are separated by plus or minus signs. I've only got one plus sign here. That is the only plus or minus sign I have. So what that means is that I only have two terms. This 2x squared times x is term 1, and the 3x squared times x is term 2. So that's step 1. Step 2 tells me that I must simplify each of these terms. Okay, so if I take term 1, I don't want to overcomplicate the situation, but if I take term 1 and I deal with its simplification. When I say it's simplification, I mean do the multiplication. So 2x squared times x. Because I'm multiplying, I'm going to have to apply this first law of exponents. And also remember, if you ever feel a little bit confused about multiplication, go back to signs, numbers, variables. So if we go signs, positive times positive is positive, sorted. The numbers, when we talk about the numbers, we're talking about the coefficients. Remember, there is a 1 in front of this x. So I'm saying 2 times 1, which is 2. And then I deal with my variables, and this is where my exponent law comes in. X squared times x is x cubed, because I add the two exponents. So this first term simplifies to 2x cubed. Now I need to simplify the second term. The second term is 3x squared times x. Now I do exactly the same thing. Signs, numbers, variables, positive times a positive is equal to a positive. 3 times 1 gives me 3. And x squared times x gives me x cubed. So this is now plus 3x cubed. So again, when you simplify each term, this is where you're going to be multiplying or dividing or doing an exponent. Always make sure you think back to your exponent laws. And when in doubt, remember S and V. Okay, so now that we've simplified both of these terms, we now move on to step 3, which is look for like terms. Now, guys, we can hopefully see here that I've got the like term of 2x cubed and 3x cubed. Both of them have an x and a power of 3. So they are, in fact, like terms, which means I can add them together. Remember, when I add like terms, the exponent doesn't change. I'm taking 2x cubes and I'm adding another 3x cubes. So I end up with a total of 5x cubes. So, whoopsie. So when we add or subtract, the only value that changes is the coefficient, the number in front of my variable. My actual variable and exponents don't change at all. Right, so what I'm going to do is I'm just going to do that because I'm going to answer Seth's question now. Please do take a screenshot. And if anyone does have a question, remember, pop it on the chat. If you want to raise your hand, feel free. So Seth asked, would question A be 1 mark? Not 2 marks? So yes, question A, we would only give you 1 mark. Basically a mark for the answer. Nice, easy question, nothing too complicated there. So you would just get 1 mark. Something like question 2, it would depend how generous we are with our marks. But question 2, I would probably give you 3 marks. 3 marks being allocated. Let's just get this right. So my 3 marks I would allocate for simplifying term 1, simplifying term 2, and then getting your answer. So question B is still a nice, easy question. But if you do it properly, you can get yourself 3 easy marks. And that's why, again, getting this stuff right is really important because we can then bank some marks. Okay, so I hope that answers your question. Okay, grade 8. So I hope we've all taken our screenshots. You're going to try one by yourselves now. Okay, so let's have a look at English. Question C. I want you to try it by yourselves. I'm not going to give you any hints, any words. Let's try question C. Remember, our goal is to simplify this expression. So let's see what we get. Remember, answers on the chat. If you have questions, ask them on the chat. How big are we? And we will help you, but let's give question C a try. And remember the two rules that we've spoken about. So the fact that when we add like terms, our exponents don't change, and the fact that when we multiply and divide our variables, the exponents will change because of our exponent laws. Okay, so just remember the rules that we've discussed. Remember how we actually go and simplify. And guys, remember, if you're identifying your terms, we only look at the plus or minus signs inside, outside of the brackets. So we have spoken about this before, but just as a reminder, when we consider like terms, we only look at the plus and minus signs outside the brackets. If those answers coming through on the chat. Let me give you another minute or so. Okay, guys, let's have a look. Right, so I'm going to follow the same three steps. First thing, identify my terms. Remember, when I identify my terms, I'm looking for the plus or minus signs outside my bracket. So actually, there's only one, which means I only have two terms here. This is term one, and this is term two. Good, Seth. Right, once I know what my terms are, I want to simplify each term. So that means I need to go and distribute. So when I get to term one here, term one, this is the 5 times 2x plus 3y. And grade 8s, I know that I'm doing my simplification on the side. I did the same thing here in question B. If you want to do that, that's fine, but you obviously don't have to. If you can distribute that and write that as your next step, that's absolutely fine. Okay, so we're going to distribute, which means we're going to multiply into our bracket. 5 times 2x is 10x. 5 times 3y is 15y. So my whole first term simplifies to 10x plus 15y. Right, when we get to term 2, this is 6 times x plus y. Again, we're going to distribute into our brackets, giving us 6x plus 6y. So this term 2 simplifies to plus 6x plus 6y. Now, guys, I know that there's a plus sign in between the two because that was my sign separating my terms. If I had a negative, we would then be distributing in a negative, and then we'd have our signs as well. So always just remember that your sign sort of leads on from what your sign was in the original expression that you had. So I've identified my terms, I've simplified each term. Now I need my like terms. Now guys, this is where once you start getting in slightly more complex expressions, grab a highlighter. Okay, 10x is a like term to positive 6x. They both have just an x variable in them. And then we can also see that 6y is a like term with 15y. And because those are my like terms, I know what I can add and subtract. If you want to write them next to each other, that's absolutely fine. There's nothing wrong with that. I personally don't do this, but there is nothing wrong with you doing that if it makes you more comfortable. And then we add 10x plus 6x is 16x. 15y plus 6y is 21y. We can't do anything else because those are not like terms. We can't go further and add them together. And that's where I'll stop. I've simplified my expression. So I thought most of you come up with that answer, one or two slightly off. I hope that we have corrected where we need to correct. Oh, excuse me. So I hope we've done our corrections where we need to do our corrections. Let's take our screenshots, and if anyone has any questions, now's the time to raise your hand and ask. It looks like we're doing really well, which is awesome. Well done, guys. Okay, so I hope we've got our screenshots. I'm about to move. Right. Okay, I'm going to change my mind here. I don't want to do this one. I'm going to give you another question because I can do that. Okay, so I want you guys to try question D for me. As you saw, once we've done this one, we'll take a little break. So let's do this one really, really nicely, and then we'll take a little brain break. Whoopsie. Again, just remember all of the rules that we've spoken about. I like that, Ina. Cannot add apples and bananas. I agree. Apples with apples, bananas with bananas. Okay, so let's give it a try. Let's see what we come up with here. Remember your distribution. Remember your exponent rules. Okay, so Taskia asked, would you say minus 3x when you start to think about your distribution? Taskia, I would say minus 3x because remember, the sign belongs to this 3. So it's actually the whole negative 3x that we're distributing into this bracket. Good question. Just remember your signs because you are dealing with a negative, as has been pointed out. Guys, just to go back to his question about the sign with the 3x. I'm not removing the question, but if you have a look in question C, I essentially was still including the sign. So this was a plus 6x. I can write the plus 6x there, or the plus 6 if I want to. I know that I don't have to put a plus sign in front of a number. If it's the first number that I'm writing down, we just know it's there. With the negative, we would do the same thing, but we would then write the negative because we know a negative is a bit different. So just because I haven't written the plus there doesn't mean that I'm not multiplying in the plus 6. Okay, I'm giving you 1 more minute and I'm going to go through it. Okay, let's have a see. So I'm going to do the setup a bit differently, just so you can see you don't have to do the working out separately if you don't want to. So again, if we identify our terms, as I've already explained, this minus sign is separating my terms, which means I once again have only 2 terms that I'm working with. Term 1, oops, let's try that again. Okay, term get better, and term 2. Right, we are now going to distribute. So we are going to take from the first term, this 2x, and we're going to multiply it with the x, and we're going to multiply it with the 4. So 2x times x gives me 2x squared. Go back to your SNV. And 2x times positive 4 gives me positive 8x. Again, think back to SNV. I'm going to do exactly the same thing with my next term. My coefficient is negative 3x, so I'm going to distribute it or multiply to the 2 terms in my bracket. A negative 3x times a positive 2x gives me negative 6x squared. Negative 3x times negative 1 gives me positive 3x. So once I've done my distribution, I'm sorted. Now it's just about getting my like terms. So my like terms are going to be the x squared terms, so the 2x squared and the minus 6x squared. And then separately to that, because the exponents are different, I've got my positive 3x and my positive 8x term. So because those exponents are different, they are not like terms to the x squared terms. So 2x squared, if we want to write them together quickly, minus 6x squared plus 8x plus 3x. Again, you don't have to rewrite them, but you can if you want. 2x squared minus 6x squared is negative 4x squared. 8x plus 3x is positive 11x. They're not like terms, so I can't do anything with that. Stop there. And I've simplified my expression. Okay, so guys, like I said, if you can follow those 3 steps, identify your terms, simplify each term, and then add and subtract your like terms, you can simplify any expression. Okay, so let's take our screenshots. If anyone has any questions, again, time to ask me. And always just remember, you can be asking on the chat throughout the example, throughout the explanation. But otherwise, we're going to take our break. And then we'll carry on. Right, I hope we've all got our screenshots. I'm about to move. Whoopsie, so sorry. Excessive. Okay. Oh. Sorry if you heard that. That was wild. Okay, so I don't know what you mean there for. Do you mean the 3 little dots? If that is the case, we only really use the 3 little dots with equations. Because what we're doing here is we're not changing the meaning of this expression. All I'm doing is I'm making it simpler. So this second step is still exactly the same as the first question. I've just simplified it. The third step is still exactly the same as the first and the second. I'm just simplifying it even more. So these are all actually equal to each other. It's just been simplified. We use the therefore with equations because once we've done some inverse operations, we can now make the next inverse operation step in order to get to our final solved value for our variable. Okay, so guys, brain break. There it is. I don't actually know if you can see the joke. Yeah, we got it. Right, so brain break. Let's give it a try. Slightly different today. We're guessing the phrase. I hope I can remember all of these. Let's hope. Right, let's see what we come up with. Ibanati, when you add two x's, okay, so Ibanati, I explained this earlier. When we add like terms, the exponents don't change. So it's what Ina said earlier. X plus x is an apple plus another apple. You now have two apples. So it's just going to be 2x. The exponent only changes when you multiply. Okay, so x plus x, you just have 2x. Right, guys, let's try this. No problem. Looking out for your answers on the chat. I don't remember if I saved the answer somewhere, so I might be making it up as I go along, but I'm pretty sure I remember them. I'm sure it myself. Okay, I'm not going to give you too long, so I'll give you another minute or two. So remember, you're trying to guess like a phrase, so you need to look at the picture and see what sort of phrase you have, what like common phrase that's commonly used do you have represented by the picture?
Come on, guys. It's supposed to be fun. Oh my word. My flu just got elevated. This is supposed to be fun. You guys need to guess. You must write everything that you think it is on the chat. I don't even know the correct one, but there's number 2 that I agree with you, Tazkia. Matthew. Yeah, is it true? Is it baseline number 2? Yeah, we got it right. I don't know about the rest, guys. I'm so horrible when it comes to this game. I'm really horrible. The only one that was so obvious to me was number 2, and y'all got it right. Oh. Whoa, whoever is going to get number 5, you are really going to be a genius. Teacher Sam just woke me up. I think we also got number 1, which is midday tea. Who got that one? Matthew got it. Sinyani also got it.
Oh, this is nice.
So 1 and 2 is gone. Nokutenda, yes, it's our last week. So you better have fun.
Okay, guys, let's have a look so we can move on. So most of you got the first one, which was midday tea. Okay, like British, but midday tea. Now we got the second one, baseline. Third one's a little bit harder. This is a high IQ because all the I's are in a Q. The fourth one is hole in one. And number 5 is uphill struggle, which, as someone said, is maths apparently for some of you. Okay, but hopefully after studying Watobe, hard work, no longer such an uphill struggle, and hopefully will continue to plateau. Hey, but well done, guys. I'm impressed with you guys coming up with these. I'm the same as you, Linda. I'm shocking at these. If I didn't know the answers already, then I don't know if I'd get them. Especially number 3. Number 3 was hard. Okay, but let's have a look. So like I said, algebra split into 2 broad sections, equation, well, expressions, which we've had a look at, and equations. Okay, so if we think about algebraic equations, our rules also apply. So like exponent rules still apply. We might need to distribute, etc., etc. But what we now have to remember with equations is that we're solving for an unknown. Okay, so we're solving for x, we're solving for a, whatever our unknown is, we're trying to find its value to make the equation true. And there's 2 important things we need to remember. Firstly, we need to use inverse operations in order to solve our equation. Don't know why my highlighter is so tiny. We have to use inverse operations so that we can solve our equation. And the second thing that we need to remember is that what you do on one side of the equation, you have to do to both sides of the equation. So basically, if you times one side of your equation by 3, you have to times the other side of your equation by 3. The reason for this is because an equation is a scale almost, it's a balance. If you're going to do something on one side to keep that equation in balance, you have to do the same thing on the other side. All right, so let's have a look at this first question. I'm going to leave the golden rules up there. I see that some of you guys are solving, and that's awesome, but I'm going to do it with you. But if you've got the answer, cool. So the first thing I would always do for myself is I would just identify where my variable is. So when I say where it is, what's happening to it? Well, it's been multiplied by 3, and then it's having 2 added to it. And by doing that, I automatically know that my inverse operations will have to be a subtraction because the initial or the original was plus, and it'll have to be a division because my original was times 3. So just by figuring out where my variable is, I kind of know what inverse operations I need to do. So the first thing that I'm going to deal with is I'm going to deal with this plus 2. What that means is that I'm going to have to subtract 2 on both sides of my equation. Now, guys, there is no need for you to write minus 2. If you want, cool. If you are happy that you can just say 3x is equal to negative 12, that's absolutely fine. But if you're not quite there yet, that's also fine. Rather write in the minus 2. So this goes back to the inverse operations and goes back to what we do on one side, we do on both sides. If I'm going to subtract 2 on the left, I need to subtract 2 on the right as well. What that does is it then leaves me with 3x on the left-hand side is equal to negative 12 on the right-hand side. Now, like I said, if you're happy to skip from the original question to that step, awesome. You don't have to do the step with the orange minus 2. So my left is equal to my right. And so what that means is that this answer that I got is correct. So always remember, and I said this to you before, I think most of you have probably written your paper one now, but even tomorrow or in the coming weeks when you're doing geometry and stuff, once you found a value for x, sub it in and make sure it is actually true for the scenario you have. Okay, so let's take our screenshots. If anyone has any questions, please ask. Oh, golly, Miss Molly. Okay, and then we're going to have a look at the next one. And again, grade 8s, you don't have to do the second step with the orange -2s. That's just to show you the inverse operations. No need for that. To be sure, we have done this answer, so I'm not too sure where the -12 is coming from. I've also just explained the whole thing. I don't know if it's a typo or what. If you have a question, obviously feel free to ask. Alrighty, guys. So I'm going to leave question A up just so that you can sort of be reminded of what we did. I want you to try question B. So remember, your whole purpose here, your mission is to solve for x. We want to get a value for x that will make this equation true. So let's give this one a try. Let's see what we come up with. Give you a minute or so. In grade 8, remember, you don't have to have x on the left. You can if you want, but if you've got x on the right and you solve for x on the right, that's fine. As long as it's equal to a value and you've got x equals or something equals x, that's okay. And remember, once you have an answer, substitute it back into your equation and check. Make sure you actually agree with your own answer. Okay, keep those answers coming. I like what I'm seeing so far. Hope we're checking. All right, grade 8, would anyone like to raise their hand to explain this one for us? Charlie?
Hi, ma'am. So, ma'am, first thing, you're gonna um take the negative 3x over the equality sign, which makes it negative 4 plus 3x, because when it goes over, it changes the sign. Yeah, equals to 8. So, and then we're gonna we're gonna we're gonna say, I'm not sure, ne? I was trying this question. Then I think you're gonna take -4 over the
Good.
equality sign again, which makes it 3x equals to 8 minus 3, minus 4, plus 4, I'm
Okay,
sorry.
+4. Good, well done.
And then 8 plus 4 is 12. So 3x equals to 12. Divided by 3. Then the 3x, yes. And then 12 divided by 3 is 4. Therefore, x is equal to 4.
Perfect. Excellent. Well done. Really good explanation there. Okay, guys, so that's exactly it. Now, like I say, you don't have to do it like that if you don't want to. You can keep the x on the right-hand side. So if you made that choice, you would now subtract 8 on both sides. So you'd have -4 minus 8 equals the -3x. -4 minus 8 gives you -12 is equal to -3x. And then you would divide both sides by -3. Negative divided by negative is a positive. And so we get that x is equal to 4. It doesn't matter that the 4 is on the left. It means exactly the same thing. You're telling me what x is equal to. So either way that you've done it, it really makes no difference. As long as you've solved and you've got x by itself, you're good. Alrighty.